Hello guys, you're welcome to Create Control Automation. Today we're going to continue from the hardware configuration that you created. So what you're going to do is you're going to design a simple direct online starter, in the Simatic Step 7300 software, right? So in the previous video we ended here, right? So let's move straight to the Simatic Manager, right? So this is the main Simatic Manager interface. See the top left corner here. Simatic Manager, right? So this is where we create our the main programs. All right, we write the programs. So we are going to use what we call ladder logic, to design this simple DOL starter. So now we have here the Simatic 300 one. All right, so let's open it inside. So we open this, and then we have sources and then blocks. We are going to click on the blocks. Over here we have system data and organization block. This organization block is the main program cycle block. So anytime the CPU want to perform a function, it calls these blocks. All right. So now let's double click on this block. So as we double click on the block, we have this interface, this window, properties, organization block. So now we are going to create the program using ladder logic. In Simatic Step 7300 or in pure programming, there are 3 languages in which you create our programs. So you see here, the name is OB1, symbolic name. You can give it a name, or write any name at all, or comment, symbolic comment. Now created in language. So this is the language in which you are going to create our program. So we have ladder. By default, ladder is being is selected. So when you click on this arrow, the drop down arrow, you see some functions here. There's some drop down functions here. We have STL, ladder, and then FVD. The FVD means function block diagram. LAD means the ladder, and then the STL means statement list. Alright. So now we are going to use ladder. Alright, ladder, because in most of the Siemens programs they are in ladder they are in ladder format. So let's select the ladder. And then we click OK, right? So here we have network 1. This is the main interface. See here, the top left corner here, the ladder, STL, FVD, they've been listed at the top left corner here. So this is the network component that you use. If you want timer, everything, they are all here. So now here, this is the ladder format. We have network 1. You can delete this network. You can delete it. It is gone. So now we are going to create a new network. You right click and then you insert network, and then we have our network here. You can click again, insert network. The second one will come, network 2. Alright, so let's delete this one. If it is necessary you have to use network 2, you create it. So for now we are going to use this first network. Alright, I told you we are going to design a simple DOL starter, right? So here, look at the top here, we have these symbols: open contact, close contact, and then quell. Alright, it resembles a quell, and it's a quell symbol or relay symbol, or output symbol. These are the input symbols, right? So now DOL starter, you need our stop, our stop button. So the moment you click on the stop button, alright, it will be added here, on the line. So this is the ladder line. We call this one rank. So from here we select the line again, and then we select open contact. That is our start push button, and then we select the line again. Then we pick our quell. Alright, this is the quell. So now it's left with our hold on contact. We select this line, the middle line. The hold on should be in parallel with the start push button. So we are going to use this one as our start push button. So we click on the middle line, we select it, and then we come to this arrow, open branch. You click on it, it extends the line downwards. The arrow is showing that we can insert a new contact. So we click on the open contact. All right, and then we can select this line, okay, and then you select close branch, okay, this contact showing the top arrow. So now we have closed the circuit like that. So now this is our simple DOL starter, okay. Yeah, how to start programming in ladder logic using Siemens Step 7300. So now you see we are having some question marks, okay, on the contact. This means that the PLC doesn't know, okay, it doesn't know this contact, okay, it doesn't know them. That's why it is showing a question mark. So for the PLC software should be able to know this contact, okay. We have something we call tagging. You have to tag them, okay. You have to address this contact so that the PLC will know that, okay, these are the contacts I am working with. So for that matter, you go to options, right? You see these options, yeah, and then come down here, symbol table. All right, okay. So we have this window, okay, we have this window. All right, so now see the first one, symbol, the first symbol. This is where we are going to write the name of this contact, okay, the name of this contact. So I told you that this contact is going to be our stop button. All right, so we write stop button here, stop button, okay, stop button, okay, all right, or stop push button, yeah. And then we come to address. The address, it is showing this number, right? Before we'll be able to know the address number, all right, let's come here. Let's come to the hardware configuration. Let me show you something here. You see, I told you these are explanations of this blocks, right? So we have digital input and digital output, right? Now our PLC, okay, the PLC module we chose from the previous video. Please, if you've not watched the previous video, please kindly watch the video to learn how to create new project and configure the hardware before you also start design the diet online, okay. So now in the previous video, okay, we chose these blocks, right? Yeah, so we have DI24/DO16, right? So we have 24 digital input and then 16 digital output, right? Okay, so if you remember here, I told you that we have this byte, okay. All right, let me show you this picture. Let me show you this picture. Yeah, so I told you that these are the digital input, all right, bit, all right. So this is DI plus 0. It means that byte 0, this is byte 0, this is byte 1, DI plus 1. Here, see here, you see the in, that means the digital input. So digital input plus 1, okay, yeah, DI plus 1, okay. So it means that is the byte 1. So this is the byte 0, digital input plus 0, that is the byte 0. It consists of 8 bits, okay. This is byte 1, also consists of 8 bits. This is byte 2, also consists of 8 bits. So 8 times 3, okay, we have 3 bytes, each byte is 8 bits. So 8 times 3 will give you 24, right? So that is why we are seeing here digital input 24, right? And then the digital output, okay, the digital output, let me show you here. This is the output. You see the first out here, right? This is the out. So D O plus 0 means that this is the digital output byte 0, and then you have DO plus 1, means that this is the digital output byte 1. So each byte is 8 bits. So 8 times 2, or 8 plus 8, will give you 16 digital output. That is why they've written that over here. All right, okay. So now what we are going to do is we are going to look at this side, okay. Before we be able to do the tagging of the addressing, okay, we have to come to this side. See here, the digital input, okay, and the digital output. This is their line. See this one, input address, output address, okay. So in the input address, I have selected the digital input. So this one, let's double click on it. Yeah, so and go to addresses. So here you have we have start. They are saying this is the input side. Okay, this is the input section. This is the input, and then this is the output, right? This is the output. So for the input, they are saying start is 124. The start address is 124, and then it ends at 126. What it means is that, okay, if you remember on our previous lesson, I told you that the byte, all right, the byte, okay, the byte, let's say the input byte. Let's come to this side. The input byte, okay, input by 0. It starts from I0.0, and then it ends at I0.7. okay, so this is by 0. This are for by 0. This are for by 0, okay, and this is for byte 1. All right, yeah. So what we're going to do is here, what they are trying to say is that we have what we have digital input, okay, starting from 24 and ends at 25, starting from 124 then ends at 126, right? So it means that this 124 is going to be our byte, first byte, okay, instead of the by 0. You see, you can equally make it by 0, okay, but they've chosen byte 24, byte 124 to byte 126, right? So now it means that you are going to start from 124 to 126 equally. You can uncheck this system default mark. You can uncheck this mark, yeah, and then enter any number of our choice. All right, yeah. So you can enter 0 here. When you enter 0, and then we click anywhere like that. You see, okay, come in. I press enter. Yeah, I press enter. So as I entered 0, okay, as I entered 0, it is starting from 0 to 2. What it means is that, okay, what it means is that, see here, I told you, okay, this is 2 bytes, right? This is 2 bytes. So if they are saying digital input 24, all right, it means that we have byte 1, okay, sorry, by 0, okay, by 0, and then byte 1, and then byte 2. Have you seen it? So now the by 0, okay, the by 0, they are saying, okay, to start from 0, okay, the whole of the byte will start from 0 to 2. That is what they are giving us here. You can see it from here. Okay, you can see it from here. See, you can see it from here. The output, the input. All right, the input 0 to 2. As we enter 0, in the start, the end was 2. It means that we start from 0 to 2. So if you are to address this one, okay, it is going to be I 0.0, I 0.1, I 0.2, I 0.3, I 0.4, I 0.5, I 0.6, and then I 0.7. So this is how the first byte will be, all right, and then the second byte will be I 1.0, I 1.1, I 1.2, I 1.3, I 1.4, I 1.5, I 1.6, and I 1.7. This will be the second byte. All right, the third byte will be I 2.0, I 2.1, I 2.2, I 2.3, I 2.4, I 2.5, I2.6 and I2.7. So you see here, we started from 0, okay, 0, 1, and then 2. So this is what it means, what they've written here. Alright, sorry, what they've written here. Okay, the moment we started from 0 by 0, we ended at by 2. So this 0 will end to be I0.0 to I0.7 as we did there. Then we come to 1 because there are 3 bytes. Based on this, the data input 24, and each byte is 8 bits. So 8 times 3 will give you 24. Okay, so that is what it means. Alright, yeah. So if we were to start at the 124, it will be I124.0 through to I124.7. Then we come to I125.0 through to I125.7, and then we come to I126.0 and then I126.7. That's how to be. Alright, if you have to start from 124, okay, like they gave us the default values, but we have changed it to 0. You started from 0, then it ends as 2, right? Okay, now let's come to the output. The output to, they are saying it is starting from 124 to 125 because it is only 2 bits, right? So here DO16, and each only 2 bytes, okay, and each byte is 8 bits. So 8 times 2 will give you 8, will give you 16. That's why we are having 16 here. Okay, so the bytes, the first byte will start from bytes 124.0 through to bytes 124.7, and then the next byte will be byte 125.0 through to byte 125.7. So we are going to change this one to the same 0 and the same 0, right? Yeah, so let's click anywhere. See, as we click anywhere, it is ending at 1 because the first byte will be byte 0, the second byte will be byte 1, but there are only 2 bytes. Alright, so let's click OK. So it will be like this, 0 to 1, right? So it will be KO 0.0, comma, okay, 2 to KO 0.7. Alright, do you understand? And then the second byte will be KO 1.0, okay, comma, to KO 1.7, because only 2 bytes. So to start from KO, to start from 0 and end as 1. Alright, okay, so now we're going to use this one to do our tagging. Okay, I am only explaining this so that you will be able to understand how to do the addressing. Okay, yeah, so we are going to use this one to do our tagging. Okay, so now our stop button, okay, because it's an input input address. All right, stop and start, they are all input address. So let's use the 0. Okay, let's use the first byte, I0. Okay, yeah, so we are coming to do it I0.0, press enter. Okay, they've given us bool. Bool means boolean. Okay, all these things are digital values, zeros and ones. Okay, so it's a boolean algebra, right? Now let's come to our start button, our start push button. All right, yeah, let's press enter. Automatically it has given us I0.1. Let's confirm from here. From I0.0 we are coming to I0.1. so we are using only 2 input. That is why let's see here the diagram, only 2 input, stop and then start. This one is a contact on this, so it's a contact on this. Okay, so these are output. Yeah, so for the input we are only using 2. Let's go to the output. That is our relay or coil. Let's name it relay. Okay, the moment you press enter or we select this box, it will continue, but we are not going to use input. Now we need output, so it will be KO 0.0, enter. That's all, because we want to use the first, there are two byte, we are going to use the first byte. Okay, but since only one, we only need one, so we prefer the K0.0. all right. Yeah, you can equally use K0.1 through to 7. Okay, or you can equally use this. Yeah, so we are done with addressing. Okay, so what you're coming to do is you click on the question mark, right? You type in any name. This is the stop to give you some related value names. Okay, you see that stop boolean, so press enter. See, it is written here. I0.0 is our stop button, and then we click, we type start. all right, you choose the start button. Yeah, enter. That's giving us this. Okay, that is the I0.1, and then we come to the output. That's relay. We type our relay, enter. Yeah, I said this one is a hold on this on the relay when you are wiring a normal direct online. Okay, this is a hold on contact, so it should also bear the same name, relay, enter. All right, so now this is our simple direct online starter in ladder logic in Siemens Simatic Step 7300 software. Okay, so now we are done with this, right? Okay, what we're going to do is we are going to now upload this ladder logic diagram, okay, in our CPU. Okay, so now we are not going to use the physical CPU for now. For those of us who doesn't have the physical CPUs, okay, we are going to use an inbuilt CPU. We call it PLC sim. Okay, yeah, PLC sim. Okay, yeah, this is an inbuilt simulator for the PLC version. Okay, yeah, so it works the same as the physical PLC model, just that for this one you can't connect push buttons, relays, or sensors to this one. You can't connect anything. It's just a simulator, but whatever the PLC physical one will do, it will also do the same thing. The only difference is that you can't connect anything to it because it's the software on this computer. Okay, yeah, so it only helps those of us who doesn't have the physical PLC models. So after teaching you or taking you through all the PLC simulation, then we start with the physical hardware connections. Okay, yeah. So now let's save this project. Come to save. Okay, then let's go to the Simatic manager itself. All right, so now you see here, this is it, simulation on and off. So we are going to click on this icon. Yeah, so as we clicked it, okay, it has given us these values. All right, see here, see this thing here, you have PLC sim into bracket TCP/IP. okay, now before we'll be able to download the program onto our CPU, okay, we need something called communication protocol. So now this is the default communication protocol the CPU has given us, okay, currently. So now we don't want this. Okay, we don't want this PLC sim TCP. No, we want PLC sim MPI. Okay, now when I click on the desktop, you see it has hidden, right? Yeah, so I want it to stay on the desktop. When I click anywhere, so I come to view and then I'll choose always on top. Okay, so when I click anywhere, it will stay on top, right? Now we come to options, then we come to set PG interface. Yeah, so you see here, you see it has already selected PLCSim.TCP/IP.1. that is what we are seeing on the screen here, right? Yeah, so we are going to change it to PLCSim MPI. So look at the bottom here, you see here we have PLCSim.TCP/IP. PIP.1. So when we select the PL system MPI, this side is going to change to indicate that now we are dealing with PL system MPI. So now let's select the PL system MPI. Let's click the OK. They're asking us questions. The following blah 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 will change. The following access paths will also change. Blah 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 blah. Okay. So you see here now it has changed to PL system.MPI, right? So let's come to this arrow, change it here. That's all. Alright, okay. And now you see this is this block. So now you see this is our PLC CPU, the CPU itself. So let me show you this picture if you can remember. Yeah, I told you have these things on the CPU. Okay, the same thing here, just that there are some few things that are not here. We have SF system fault, that is here on the top. We have DP, this one doesn't have the DP. Alright, yeah. And we have DC, this DC. We have BF is not here. We have force is not here. We have run is here, and then stop is here. Alright, yeah. We have this run stop buttons, and then there are this ones. Okay, but this one is having run program, run P, but it is not here. But we have memory reset, it is here. Okay, now these are the output, and then the input. Okay, this is the CPU itself. Okay, this is the CPU itself. This is the input byte and then the output byte. So you can delete it. Yeah, you can delete it. For the CPU, you can't delete it. Yeah. So now I showed you that I'm going to show you how to create new input and output byte. Okay, you come to this side. You see here. You see this first one. This icons. The first one is written what? Insert input variable. So you click on it. It is here, right? Let's click this one. Insert output variable. So you click on it. It's also here. Okay. So now we are going to download the program. Okay. We're going to download this program, all right, onto the PLC using this communication protocol. Now it has chosen selected as we close this one, it has selected this one back again. So let's go back to the options, Siemens, PLC MP1. Yeah, as I try to close the PLC, it reset the communication protocol. So let's come here and then choose from here. Yeah, without selecting it from the options, when you select PL system MPI from here, it will not work unless you change it from here first. So this is the default, the main default place. So now we are come to use the PL system MPI to communicate or to download the program from the Simatic manager to our CPU. So if we were to do with the physical PLC models, okay, the CPU itself, right, like this ones, like this, okay, like this, okay. So what I would have done is I would have connected. I want to show you some picture here. Yeah, you see this side. This is the MPI. You see the first MPI here, right? So if I would have been dealing with the physical model, I'll connect an MPI cable here. I'll show you that MPI cable. But before then, I want to take you through. The use of the PLC simulation, so that those of us who doesn't have the PLC will be able to do PLC programming. Whatever you want to do, you can do it with this CPU model, the simulator. All right. Yeah, just that you can connect everything to it. No. So if you are to do with the PLC physical model, you use this side. Okay, I'll connect a cable here and then I'll connect it to the laptop, so that I'll download it from the laptop to the CPU. Alright, but now we are not using the physical model. Okay, for now you use it, but I want us to finish with the simulation first. So so we are going to use this. So this is our simulator. Alright, now you see here they've written QB0. That means output by 0. Okay, and if you can see from our tags here, the tagging, right? our output is what? KL 0.0. So it means that it is okay. Okay, and we come here, you have IB 0, input byte 0. So the input byte 2, we are using the byte 0. Okay, byte 0. But byte 0, you use byte 0 and bit 0 up to bit 1. Okay, but for the output byte, you use byte 0 to byte 0. Byte 0 to bit 0. Okay, so now what you're going to do is you go to the Siemens. Okay, let's come here first. Okay, save and compile, right? And then you come to this arrow, you come to download this one to the PL system. Okay, so the down arrow, we have download, this one is an upload. So let's come to download. Alright, yeah, you select view. Okay, update. Okay, so now we're done with the download. Alright, so let's go to the Simatic Manager 2. We select the Simatic 300. We click on this download. You see the download? Click on it. Do you want to delete the system data in the programmable controller completely and replace them with offline system data? Yes. Yes. So we have finished downloading it. Okay, yeah. So now we have downloaded the program, okay, onto our CPU now. Okay, onto our CPU now. So now let's click on the run program. Run. You see that the light is blinking the same way as the physical CPU. Now we are running our CPU. So let's go to the ladder interface. You see this icon here. Now whatever the PLC, whatever program it will be doing, we can't see it because now we are in the offline mode. Offline. We are now coming to go into online to see this contact, what they are doing really. Okay, so by that you click on the spectacles. So as we click on it, you see they have changed. Okay, right, let me go back for you to see. You see now in the offline they are black. You don't see whether this one is closed, you don't see anything, or open. But when you click on the spectacle, you see it is showing what? Green line. Green line. Let's look at it down here. We have run light, green line blinking on and off, right, going back and forth. So now here, okay, we have two rails. This is our positive rail, positive line. This is our negative line. This side is our negative line. This is our positive line. Now if you remember, stop push buttons, okay, they are always normally closed. Stop push buttons are always normally closed. So see here, it is showing close. So now current is flowing through this close contact and it is ending us this side because this contact is open. Start button. So that's why you are seeing a green line showing current, okay, positive side. But because this side is open, there's no way it can flow through to energize the relay. Okay, so now what we are going to do is, he said we are starting from where? I0.0, right? I0.0 to I0.1. So now I0.1, I0 is our byte address, and then the 1 is our bit address. Okay, so we are going to operate this switch using this input byte. So now this is our byte 0, input byte 0. Okay, yeah, and now this our bit. These are the bit numbers, bit 0 to bit 7. So if you remember here, you see I0.0 to I0.7. So this is it, 0 I0.0 2.7. Let me go over I input byte 0.0.1.2.3 through to .7. So now our start, okay, address is I0.1. So it means that we are going to use I0.1 here. So let me send this one off. Okay, so if that's the case, now you see here we are going to click on, we are going to check this one. The moment we click on it, all right, this contact is going to close. So let's click on this. You see that? See here, see it is now showing green. So now the current is not, so it means that it is closed, and now current is flowing through this closed contact to energize the relay. Now the relay is energized. You see that as it's energized, see this contact is also on this relay, so it is also energized. But now what this thing means is that, okay, you see the one is still checked, it's still marked, right? It means that my hand is still on the start push button. I have not released my hand, so it is still remaining closed. Okay, so now I am going to remove my hand. Okay, it's like an open switch, so I'm taking off my hand so that it will come back to its normal open position, right? So I'm going to do that by unchecking the one again. I've unchecked it, right? See here, it is open back again, right? It is open back again. Now you see here, because this one is a hold on contact on this, so current is still flowing through this side, through the hold on contact, which is now closed, through to the relay. So the relay is still energized because now I have released my hand from the start push button. Still, it is still energized. Now let's see the relay output. The relay, this is by 0, okay, output by 0. Now because we use bit 0, now that the relay is energized, the bit 0 should also energize. So see here, automatically it is checked by itself. It has checked it. It is checked, alright, automatically, because that relay is energized, and we are energizing bit 0. So if it was a physical PLC model that you are using, right, like this one, okay, there is the output. So if it was to be a physical PLC, all right, so it means that you see this 0, this side, this is byte 0, this is byte 1, output by 0, output byte 1. So if it was a physical PLC, 24 volt is going to be from here, this contact, this one, that corresponds to the 0. So we are going to get a 24 here, 24 volt here, and this 24 volt will be given to a relay to energize it. That is what it means. Okay, yeah, the same applies to the start. So when you press, we send a 24 volt DC to the input by 0 bit 0, okay, to energize. So we come over to that later. Now we are on simulation. Okay, so now that is it, all right? So now it is energized. Okay, so this CPU, this simulator, it can do everything, analog, everything. The only difference is that you can't connect a push button, relay, transmitter. You can't connect anything. You can't connect anything. That is the only difference. But if you want to learn pure programming, you can use this simulator to do whatever the physical PLC model will do. This one will do the same thing, just that this one is a simulator. So you can be in your room and practice PLC programming using this. Okay, so you are going to thoroughly go through the process of using the simulation. We will create so many projects using this before we switch over to the physical models, how we will connect, where we connect the cables, wires, everything. But for now we are on the simulation. All right, so this is a simple direct online diagram in this Simatic Step 7300 software using the ladder logic. Okay, so now we're going to off this circuit, or we're going to de-energize the relay by pressing on the stop push button. Okay, so now the stop address is I0.0, right? So we come to the input byte. Okay, so input by 0, that is it. All right, input by 0, and then this 0 is the bits. So now input by 0.0. So we are going to check this thing. We will check it. So we check it. You see that now my hand is still on the push button. So now this contact is still open, right? The current is only at this side. All right, so it can flow through this side. Okay, now the relay is de-energized. So let's see the output. You see, automatically it has been unchecked. So now I'm going to release my hand from the stop push button. So let's see here. So I'm going to do that by unchecking the 0. You see that? So as I uncheck the 0, all right, you see it has come back to its normally closed position. So now the current is again flowing through to this side. It is waiting for this contact to also close so that the relay can energize. So seniors, engineers, this is a simple DOL starter. Okay, I'm using ladder logic in Simatic Step 7300. In my other videos, it is not going to be lengthy like this. I only took my time to explain to you the process of doing the tagging or the tag address, creating the ladder logic, everything. So my next video, I'm not going to go through all these things again, all these things again, because now you know the byte and the bits. Okay, so if you are new to this channel, I'll urge you to subscribe to this channel, and then you hit the bell icon, select all for more videos, so that you're not lost. Okay, so make sure you share this video to your friends, you like the video, put down a comment. If you don't understand anything, let me see it in the comment section. Okay, yeah, my email address is there. If you want the software, the download link for this Siemens software, it is in the description. So open the description, go down there, it is there. There are two, the software and the license key. So download the two softwares, the software itself and then the license. All right, and then the process of activating the software, the video is there. So make sure you search through how to install Simatic Step 7300 and activate it. That my video is there. Make sure you watch it. All right, so I'll see you in my next tutorials. Thank you.